Okay, second subtopic, which is on root mean square, also known as RMS. Okay, so in this subtopic, you should be able to define what is RMS for current and voltage for AC source, and then use these two equations lah. Okay, so let's look at the IRMS, which is root mean square current. So it is basically defined as the effective value of AC, which produces the same power, which is the mean power over the average power, as the steady direct current when the current passes through the same resistor. Okay, so that is basically the definition for RMS current. Okay, so the equation is basically the power for direct current should be equal to the average power for alternating current. Okay, so I square R is basically the power for direct current equal to the product of average current square of the average current times dengan the resistance lah. Okay, so you will then get this equation here, and then from here you can then say that IRMS is basically equal to this equation here. So I equal to IRMS lah. Okay, so the mean or average current pula, it is the average or mean value of current in a half cycle, which flow of current in a certain direction. Okay, atau mathematically you can just write it as this one here. Okay, so since AC current is I equal to I naught sine omega t, and IRMS is equal to this one, we can then let IRMS to be equal to this one here. Okay, and sine omega t square is basically equal to 1 over 2, so we'll then get IRMS equal to I naught over sine 2. Okay, so that is basically the derivation of the equations lah. Okay, so you don't have to know how to derive the equation, you just have to know how to use these equations lah. Okay, so for this definition here, in graph it can be shown like this lah. So IRMS current is the effective value of AC kan, so it is just up till here. IRMS, it won't be at the peak lah. Peak current is I naught lah, it's not IRMS. Okay, and then we have the root mean voltage. So actually I forgot to add square here. Root mean square voltage. Okay, so we have root mean square voltage. It is defined as the value of the steady voltage, which when applied across a resistor would produce the same power as the mean average power produced by an alternating voltage across the same resistor. Okay, again, you don't have to know how to derive this, you just have to know how to apply this equation here. Okay, so both these equations is only valid for a sinusoidal alternating current and voltage. Okay, all right. So that is the theory part for our second subtopic. We'll look on to examples in the next videos.